Hey, in this SimMan simulation, an important thing is to realize that as we push, we're going faster and faster and faster. The one speed that we really know is the fastest that our sim guy can push, and that occurs right here at 45 meters per second. So when you do a lot of your timing, it'll involve that. Make sure that you have that down. So I'll end up as soon as I start this, I can count, 1001, 1002, 1003, so on until I get to this point here, and I know my velocity has changed from 0 to 45 meters per second. Let's go and take a look at the report. Okay, in this one, let's scroll on up. Here, let's take a look at the calculation. Okay, hey, so we've applied a certain force. You can adjust that with the little slider. The mass change in speed. Why is it 45 meters per second? Because we're going from 0 to 45 meters per second, the point at which our SimMan falls down. The time till fall is a time from when we start pushing until SimMan falls down. Okay, so just go ahead and time that on a watch. You can count it, whatever way you can kind of get a reasonably accurate amount of time. And acceleration is our change in speed listed here, okay, divided by the time it takes to fall. That time it takes to fall is the time that it took to go from 0 to 45 meters per second. For example, let's say it took 10 seconds. We would have 45 meters per second divided by 10 seconds. 45 divided by 10 would be 4.5. And our unit, meters per second divided by second, meters per second, or meters per second squared. Take a look at this question. Is there a relationship between the direction of the net force and the acceleration? Hey, so I sure hope there is, that the direction that we apply a force is the direction of our acceleration. Hey, our second chart here, notice in this case our force stays the same, but we're changing the amount of mass, from experiment to experiment. Okay. Hey, so again, you're going to measure the time it takes till he falls. And the acceleration. Again, our change in velocity is going from 0 to 45 meters per second, the speed at which SimMan falls down. The time is from the time we start pushing till we get to 45 meters per second. The acceleration is really just that change in velocity or change in speed divided by our time. Okay, let's look at these other questions here. Hey, is there a relationship between the magnitude of the acceleration and the mass? Okay. Hopefully what you're finding is that there is an inverse relationship. As mass goes up, you should find that acceleration is going down. As mass goes down, acceleration goes up. Okay, that's going to be an important item when we look at our relationship in Newton's second law. Acceleration is equal to force divided by mass. What that's telling us is that acceleration has a direct relationship to force and an inverse relationship to mass. Go ahead and fill out all these. Hopefully you already have and submitted it. If you want to revise this, you can. Good luck.